Hi friends, let's start our discussion on mechanical solids with the first concept called axial loading. Axial loading. As the name suggests, the loading is axial in nature. So to define that, let's suppose some shaft like this, which is having some diameter d. Let this be the center line of this particular shaft, and if the load that we are applying or disposing due to some manner or some other reasons, if the load P that is applied on this member normal to the cross sectional area, then that type of loading is called axial loading. So what we have to note, that loading that is normal to cross section of the member is nothing but axial loading. Generally, the loads that are acting outward of this particular member are treated as positive. Generally, the loads that are acting out of this member is treated as positive, or the positive load P, what is also called as tensile loading condition, and also the loads that are acting to the cross section or towards the cross section are generally treated as negative loads, and they are called compressive loads. Compressive loads. And this is the normally chosen or normally used sign convention for the axial loading concept. So that's about the single particular element that is subjected to some kind of loading or some kind of constant loading. Let's suppose some other shaft like this, which is having variable diameters. Which is having variable diameters like this, and also let's consider one more step like this. And if we are having the diameter d1 over here, and we are having diameter d2 over here, and we are having d3 diameter over here, and let's suppose this is the central axis of this particular shaft, then if the loading, as we already mentioned, we are providing axial loading, and if we are providing some load P1 over here like this, and we are providing some P2 load over here like this, and here we are also applying some P3 load like this, and at this point it is subjected to some P4 load like this. And for different diameter, we are providing some different section names like A, B, C and D on this. And if we want to determine the load that is acting on this particular section AB, what we have to do is that make a section line on this particular member like this, and determine what is the amount of the load that is acting either on the sides. For that case, let's suppose this section, there is section left of this particular section line like this, and we can see that some P4 is acting over here, P4 is acting over here, and this is a section line X1. So what we can understand is that whenever we are taking the equilibrium condition of this particular member, what we can write is that, let's suppose this is the coordinate that we are using, then this is positive x and this is positive y. So from this particular member we can write from the conditions of equilibrium, P3 plus P1 is equal to P4 plus P2. Okay, and if we are considering the equilibrium of this particular section only, what we can write is that P4 is equal to net force that we are writing over here. Let's suppose this is P, and if we want to determine what is the value of P from this particular equation, we can determine P is equal to P3 plus P1 minus P2. So this will be the force that is acting over here, and P4 is the force that is acting over in the left section of this particular number. So in this way we can determine the what will be the loading that is acting on a particular member or member which is having variable loading conditions. Okay, so the catch is load acting on a section on is equal to algebraic sum of all the forces that is acting on either section. Okay, so this is the catch of this particular lecture, that the load that is acting on a particular section of the member is equal to the algebraic sum of all the forces that is acting on either side of the section that we have drawn on a member. Okay, so if we are considering the BC section, let's draw some section line like this. X2 be the section line, and for that case, if we write the equilibrium conditions, or this using this particular equation, we can write the load acting on this particular member BC is equal to the algebraic sum of all the forces acting on either side of the section. And from this, if we are considering the left section, then we can write the load acting is equal to P3 minus P4, and this is also equal to load acting on the other side of this particular section, which is equal to P1 minus P2, that is at a right of member section. Okay, so this is the catch of this particular lecture, and thank you.